This is geotrig, lesson 11, day 2. We're going to continue, guys, with inscribed angles and arcs. They're intercepting arcs. You should know that if you have an inscribed angle, it is half of the intercepting arc. But then we can twist that around and say, hey, if I know an inscribed angle, the intercepting arc has to be twice that angle. Central angles are the same as this intercepting arc. We should also know that all the way around a circle is how many degrees?
360.
360. So those are all things that we should take in consideration when doing these problems. Now, if you're trying to follow the flow of the outline, I skipped a problem. We're going to go back to that one because I found that in the other classes, they found this one to be easier. So let's start with a little bit easier one, and we'll build up to the little bit tougher one. I would think it's pretty easy to find x and y. Pretty straightforward here. Because 35 and 75 happen to be inscribed angles. So, does everybody understand or see that if I take 35 will go from here and open up here and then go to here. So this arc right there is opening from 35 degrees. You guys see that?
Yeah, it equals 70.
So it is, y is equal to 70 degrees because it's twice 35. 35 is the inscribed angle, so the arc is twice as big. Does that play out nicely somewhere else as well? I would hope you say sure.
Sure.
Look at 75. Doesn't 75 go from here to here? So that means this is the intercepting arc to the inscribed angle of 75, which means that x is equal to 150. 150 degrees. It's twice 75. We need to find z. Now there actually are two methods to find z. Nick, what do you say?
You have to find the angle that doesn't have anything right now.
Okay, so you want to find this angle.
Yeah.
Okay, what is it? What's 75 plus 35?
110.
110. All the way around a triangle, all three angles add up to 180. So 180 minus 10, 110, 70. And then therefore, I'll change colors again. You're going from here to here, right? And that opens from 70-degree inscribed angle, so it ends up being 140 degrees. That's not the only way. How many degrees are in a circle, guys? It's 360. Yeah, so it's all equals 360. If you know this is 150 and this is 70, can't you find z by saying what's 150 plus 70?
Subtract that from 360.
It's 220. What's 360 minus 220?
That right up there.
140. So there's two different ways, guys. We could use the inscribed angle stuff, or we find it by using simple subtraction. So let's back up and do problem number 2. I think this one's a little bit tougher than the problem we just did, but use the same strategies. You may have to realize that they give you 50. That's awesome. But 50 really only represents the arc right here. It does not represent the actual inscribed angles arc. But you can use that in conjunction. So I think Z is probably the easiest one to find right now.
Yeah.
Try this one on your own first. Okay,
I got the answer.
let's take a look. I think Z is the easiest one, the one you should do first. Guys, Z itself is here. And again, Z starts here and goes all the way to over here as an arc. There is no inscribed angle to Z itself, right? But do you guys realize that if I start at this and go from here to here, I will have one large arc from 80. And that large arc will be a total of
160.
160 because 80 times 2 is 160. But here's the thing. What are you saying? Why is it 110? You got to subtract 50. Guys, if I had to write an equation, it'd be Z, which you guys can hardly see up there, I'll change. Z plus 50 equals 160. Subtract 50, or not x because it's Z. Z equals 110. So that's why I can go back here and put it as 110 degrees. That is actually quite nice. Yahweh. So,
Jesus?
now, think of this. What if I told you the next variable we could solve for is x?
Show me how, Mr. Conche.
I shall show you how, Braden. Think of this. 160 is on this side of the circle, and it is the arc to that inscribed angle at 80. Right? That's why we have it in yellow. But look on the other side at x. Where does it open to? Wait a minute. It opens to the exact same start and stops, right?
Yeah.
But it is opening the other way. One's facing one way, like I'm facing to you guys, and another one's facing back to me. So, therefore, if you think about it, we have
Shoot, I got it. It's 200.
this side. This side is the other half of the circle, not full half, right? How many degrees is that red arc? It's 200 because 360 minus 160.
And then the angle x is 100.
X is 100 because x is an inscribed angle and it's half of the arc. It's not that bad. But you had to understand that, right? Now, the only thing left is y. So let me check this for us.
Oh, wait.
Y goes from here to here. So, how can I go, I think, not directly, because I don't have the green arc, do I? Do you guys notice that you guys will have to do a roundabout way to find y? What are you given, though? Hmm?
We have all three other degrees.
What's across from y? 75. Where does 75 open to?
The same point.
The same points. So maybe I'm not finding the green all the way around, or whatever this is, but I can find the other side, which would be how far? How far would this be? How far is this? 150. And using the same exact logic that I used for x, what does that leave me for the green arc? It leaves me with 210. And what's half of 210?
105.
105 degrees. And you got it. Okay, let's shift gears here. We're switching over to this. Now, guys, this looks a little confusing at first because when I created it, it was very hard to get all the numbers closer to where they should be. The 15 is representing the length of this segment. 20 represents the length of this segment, x plus 5 and x plus 10, okay? Guys, this one is going down to that chord idea that when you have two chords that cross, their pieces multiplied together equal each other. Pxy equals pq. We did that the other day. Xy equals pq. So, that means it's really easy to set these up. 15 times what? X plus 10 equals 20 times x plus 5. Guys, what this ends up solving or setting up is a algebra 1 type problem. Distribute the left side, distribute the right side, solve for x. Now, be careful because it may not ask what is x. They might say find the actual length of a chord. So therefore, you would have to put x back in to then find the distance or the length. So be very careful on what they're asking. For now, I'm just saying find x. So it's 15x plus 150 equals 20x plus 100. And as you can see, that is definitely very much like a multiple step single equation, right? Subtract 15x. Minus 100. 50 equals 5x. X equals 10. And you're done. And the last thing that we're going to talk about today, we're going to talk about the quadratic formula. This is where I have my biggest issue. I technically should not have to teach this quadratic formula. You guys have already had Algebra 1, which maybe you were introduced to it, maybe not, but then you guys did have Algebra 2. You guys should have seen quadratic formula in Algebra 2 when solving quadratics. You guys may have even learned a nice little song we're not going to sing in this class. So,
Why not?
what we have is quadratic formula, when it's done correctly, will always give you the correct answer when solving a quadratic. Even if those answers turn out to be nice numbers, even if they turn out to be not so nice numbers, things like square roots, and even imaginary numbers, where you poke an eye out and then you can have eyes. Now, guys, here's a cool thing. This quadratic formula is really just completing the square. Because if you remember back, the very first thing you did with quadratics is you tried to factor them. Sometimes they're factorable, sometimes they weren't. Sometimes the thing is you found out that you can't always factor everything because you can only factor things that have nice numbers. So that's why we taught you the quadratic formula or completing the square, because they can handle all of them. What if I told you that somebody at some point took a very generic quadratic form, ax squared plus bx plus c, and they used the steps for completing the square, creating a formula that was nicely, neatly packaged and wrapped up and ready for you to use. So, guess what? I say, if you can build it, you can use it. So what we're going to do, we're going to use completing the square, and we're going to build the quadratic formula. I hinted at earlier that, hey guys, at the end of this hour, I will give you an extra credit opportunity. Here it is. You take it, you leave it, you don't argue about it, don't ask questions about it. On the next assessment, not the one you guys are taking home, this next assessment for lesson 11 and on, there will be a bonus question, and that bonus question will be, use completing the square to create the quadratic formula. I'm basically telling you right now we're going to work on it together to do this. So if there's any words, you might want to write this process down, listen to my words, so you know how to do it. I think it's actually quite nice. It's elegant. Okay, there are about 6, 7 steps to completing the square. The first step was isolate your variables from all else, correct? Well, here's the thing. Someone's looking at that going, well, there's A, B, C, and X's. Those are all variables. And I'm going to say, absolutely. So how am I supposed to separate them? Here's the thing. If I'm working with a quadratic, A, B, and C are not variables. They are numbers. So therefore, I'm not going to treat A, B, and C as a different variable. I'm treating it as a number, or aka a constant. So when I go to using step 1, the only thing that I can separate my variables from is C. So I'm going to subtract C from both sides. And I'm hoping, whoops, everybody could do that. So would you guys agree if I put C to the other side to be a negative C equaling ax squared plus bx? Step 2. Step 2 says what? These are all things that are in your notes. Make sure A equals 1. You're looking at that. A right there is A. Can I guarantee that A is 1 right now? Could it be 1?
Yeah.
Yes. Could it be 3?
Yes.
Negative 5?
Yeah.
Sure can. So, what's the best way to, like we've been doing for all of our other problems, to guarantee that A itself, in that position, is 1?
Substitute 1.
Divide by itself. So, I'm going to divide by A. But remember, what I do to one thing, really technically I have to do to all things. Essentially, as well, what I do to one side, I do to the other, then distribute the dividing by A, or 1 over A to everything. So therefore, that's why everything gets divided by A. The A's will cancel. And so you're left with negative C over A equals ax squared plus b over ax plus something plus something. Oh, wait a minute. Hey, you guys remember that? I added those plus somethings when we were doing completing the square. I was only able to do that when A equaled 1. I just made A guaranteed to equal 1. B was B, right? If you look at the very beginning, B was B. What's in the B position now? What's in the B position?
B over A.
It's B over A. It's a fraction. What was the rule that we had to do to add to both sides? What are we adding to both sides?
Oh, B over 2.
B over 2, right? Half of B squared. It's a fraction. So I'm not going to divide it by 2. I'm actually going to multiply by half. And so, if I'm going to take it over here, B over A times 1/2. B times 1?
B.
A times 2? 2A. So this becomes B over 2A squared. And remember, decide with the variables, I'm purposely leaving it inside parentheses squared. But then, how do I square a fraction? Square the bottom, square the top. What's B squared? What's 2A squared? 4A squared. You guys agree with this? Next up in our process was factor one side, simplify the other. Hey, there was a really good reason why I left it like this, because when I go to factor that right-hand side, I know the answer is going to be x plus b over 2a. b over 2a. But now I have to simplify the left-hand side.
Put x over 1.
The thing is, that's two fractions being technically added or subtracted there. So they should have a common.
Denominator.
So, what's the common denominator? 4a squared. 4a squared's on the left, but the right one does not have a 4a squared. So what's missing?
The square.
4a. Because 4a times a is
Squared A.
4a squared.
what you do to the bottom, you have to do to the. So, would you guys agree that this becomes b over 4a squared minus 4ac over 4a? Oh, it's a square. Hey, we now have a common denominator. Can I put them together? Absolutely. So, that should be b squared. So, b squared minus 4ac all over 4a squared equals,
X plus b over 2a.
is this starting to look familiar? B squared minus 4ac? To get rid of the square, because you got to solve for x.
Square root.
Where do you get it?
Now, hold on. When you're square rooting, solving for x, you can't forget plus or minus. I would think the square and the square root cancel each other. That's awesome. That's x plus b over 2a. How do I square root a fraction? Square root the top. Square root the bottom. Okay, so this is plus or minus square root b squared minus 4ac. Awesome. And if I square root 4a squared, I get 2a.
Wouldn't it be plus or minus 2a?
Nope, because the plus or minus is going to go to the top or just to the bottom. You will not get both. You're only going to use, it's only going to be applied once. Okay, so now we got to get x by itself. So therefore, I'm going to subtract, right?
Right.
b over 2a from both sides. Where does it go when you bring it over? To the beginning or in front, right?
Just pull that thing all the way.
So, resulting in x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. They have a common denominator. So put it together. X equals opposite of b plus or minus square root of b squared minus 4ac all over. You just built the quadratic formula. Isn't that awesome? What we're going to do is I'm going to stop here. There will be some examples tomorrow or when we come back. I'm not sure yet. And what we'll do is we'll kind of put lesson 11 done and put it to rest and start probably lesson 12. Your homework is day 2, 6, 7, 8, and 19. Don't forget to pick up the test on the way out. Have a great day.